The overall goal of this work is to demonstrate the critical steps needed for synthesis of block copolymer materials by ring-opening anionic polymerization and to show the necessary flow of studies for block copolymer micelle formulation of a hydrophobic drug.
This protocol demonstrates the proper execution of the necessary steps and procedures for the synthesis of block copolymers by anionic polymerization.
The main advantage of ring-opening anionic polymerization is the synthesis of materials in good yield and low polydispersity, as well as the scalability of the process.
This is an exciting time for polymeric drug delivery, with a number of drugs relying on formulation in block copolymer micelles, now in late-stage preclinical or clinical development.
Prepare reagents and materials for the transfer as described in the text protocol. Weigh methoxy-polyethylene glycol with a molecular weight of 5,000. Add the mPEG into a dried flask containing a stir bar and seal the flushing adapter with a septum at the top. Connect the flask to the manifold and purge the flask for 2 to 3 minutes with argon. Turn the valve to the vacuum position to purge the flask. Rotate the flask manually and dry the reaction vessel homogeneously with a blow dryer or heat gun until the mPEG melts. After 1 minute, break the vacuum by turning the valve on the manifold towards the argon position with several quick snaps to cool down the flask. Keep the polymeric macro initiator under vacuum for approximately 2 hours and then under argon before the reaction begins. Next, mount 2 high vacuum distillation apparatuses which have been dried previously in an oven under the hood. One apparatus is for the distillation of DMSO,